Hi everyone and welcome to my channel. Recently, I bought my very first FPV drone, and this is CetusX. I've been flying it for already about a few months now, and as soon as I got a bit better at flying, well, at least better than this, I figured it was time to start record my flights for my friends and for the internet. Luckily, the drone kit comes with the goggles that has a built-in DVR feature that allows me to record my flights. However, as you can see here, the footage isn't perfect. There is a lot of interferences and the format isn't the best, but I found the way to get much better video quality. This is RunCam Thumb Pro 4K camera that weighs only 15 grams. It is going to help me to take my footage from this to this. In today's video, I'm gonna show you how to install this camera on your CetusX. We will unbox the camera, go over the components you will need, and I will guide you through the full process of installation, including some soldering. I will also explain how to set up the camera, and in the end, we will take a look at how to stabilize your recorded footage for the best results. RunCam Thumb Pro is a small action camera designed for lightweight FPV drones. It doesn't have built-in battery, so there is a connector for the power supply. You can find a micro SD card slot under the cover on the rear side. The camera comes with a micro USB port for connecting it directly to your computer or the smartphone. I will use this 2-pin power cable from the package to connect the camera to the drone power supply. Here the included to the package mount, which I'm gonna use to install the camera on the drone. The screws comes with the drone kit, and they are perfect for securing the camera mount to the drone frame. But if you have an access to the 3D printer, this camera mount is specially designed for the CetusX drone. The camera requires 5V power supply, which is available on the flight controller. However, this voltage is not well stabilized and the camera may shut down or record intermittently under the high motor loads. Therefore, it is necessary to install a 5V stabilizer. Any voltage stabilizer can be used, as long as it can maintain stable 5V with an input voltage range from 4.5 to 5V. In my case, it is an adjustable stabilizer, and I will show you how to set it. First, remove the 2 screws securing the camera housing. Once they are removed, pull up the camera and carefully disconnect the camera cable. Flip the drone over and disconnect the 4 cables leading to the motor. Then, remove the 4 screws which hold the flight controller cover. Removing the cover will give you an access to the flight controller itself. Now let's take a closer look at the flight controller. Depending on the year of manufacturing, your controller may be a little different. On the flight controller, there are 3 points providing stabilized 5V power. The first and the simplest option is a 2-pin SH1 connector located on the edge of the board. By having such connector, you can avoid soldering wires directly to the board. The second option is the same pins of OART connector. If you cannot buy SH1 connector, soldering wires here is the easiest alternative. The third option is the same contact pads where the power wires of the drone's main camera are soldered. I will demonstrate the soldering process directly onto the flight controller. You will need 2 additional wires for soldering, which luckily comes with your voltage regulator kit. In the video, I've shown 2 schematic options for how to connect the power wires. Start by applying a bit of flux to the contact pads. Before soldering the wires, they need to be tinned, covered in solder. To do this, apply some flux to the wires. Then bring them to the solder and heat with a soldering iron. Once the wires are tinned, place them to the contact pads on the board and heat them with a soldering iron. The black wire should be connected to the pad labeled as G and D, which means ground, while the red wire goes to 5V pad. After you solder the wires to the pads, check the strength of the connection by gently tugging. But be careful not to pull too hard, as this could lift the pad off the board. After soldering, clean the board to remove any leftover flux, using alcohol and the toothbrush. It is also a good idea to check your soldering by testing it with a multimeter to make sure there are no shorts. Start by twisting soldered wires together. This will save space and make them easier to use. Run the wires going to the camera through the hole in the drone body, and then install the flight controller on its place. The fork connector for the motor's power should be facing the bottom of the drone, and the battery wires should be facing the back of the drone. Make sure you didn't lose the vibration rubber spaces. Finally, put the flight controller cover back on its place and secure it by tightening the 4 screws. Plug the motor power cables into the connectors. The voltage regulator has 4 contact pads, 2 for the not stabilized input voltage and 2 for stabilized output. The wires previously soldered directly to the drone should be connected to the regulator's input, which labeled as VIN plus and VIN minus. First, apply a bit of solder to the regulator's contact pads. Place the pre-tinned wires onto the contact pads and solder them. It is very important not to mix them up. The red wire, 5 volts, should be connected to VIN plus, while the black wire, ground wire, goes to VIN minus. After soldering, gently check the connection strengths and then clean the soldering area with alcohol. If you have an adjustable voltage stabilizer like mine, you will need to set it to 5 volts before connecting to camera. You will need a flathead screwdriver, ideally plastic one, to avoid accidentally shorting anything, and a multimeter to check the output voltage on the stabilizer. Connect the drone's power supply. Set the multimeter to measure the voltage within ±20 volts range. Adjust as needed if your stabilizer operates in a higher range. Place the multimeter probes on the regulator's outputs contacts, Vout plus and Vout minus, with the red probe as positive. The multimeter display will show the current output voltage. In my case, it was 17 volts, much higher than needed, so I adjusted the stabilizer with a screwdriver until it was exactly 5 volts. I would also recommend to mark the potentiometer's position. In this way, if it's accidentally moved, you can easily return it to the correct position without using the multimeter. As I mentioned earlier, the camera's power cable with the correct connector was included to the camera package. I will be soldering this cable to the regulator's output contactors. The process is the same as before. The red wire connects to the positive output, Vout plus, and the black wire to the negative, Vout minus. One final reminder, be sure to clean the soldered area with an alcohol. As I mentioned earlier, if you don't have a 3D printer, you can still adapt included with the camera package mount for your CetusX. To do this, you will need to drill 3 mounting holes in the drone's camera housing. The screws I used are spare ones from the drone kit. I use a drill bit slightly smaller than the screws, so they could create their own threads in the plastic and hold securely. Next, attach the camera mount to the drone's body and assemble the drone. The screws are short enough so they will not touch the drone's camera once it is installed in the housing. Connect the main drone camera to the flight controller with the cable and place it back in the housing. Then, secure the housing in its place with the 2 screws on the sides. The voltage regulator fits perfectly on the back of the camera mount. For the next steps, we will need to power on the camera. It will not work without a microSD card, so insert one now. Place the camera on the mount and connect the power cable. Since we haven't secured the voltage regulator yet, make sure it doesn't touch any metal parts of the drone or table. Connect the drone's power supply. The camera will power on, indicated by red light. This light signals various camera statuses, all displayed on the screen. Once you confirmed that the camera is working, you can secure the voltage regulator to the drone's body. Following FPV tradition, we will use a zip tie. Trim any extra lengths with the wire cutters, and with that, the assembly is complete. Now let's set up the camera. Download the app on your phone and select your camera model. I won't go over each setting in this app, as these are best to explore on your own or with online resources. With the camera powered on, press the button on the camera body twice. The indicator light will turn green. In the app, select the settings you want to generate the QR code. Hold the camera up to your phone screen to scan the QR code. Once the setup is complete, the indicator will automatically change back to red. To start recording, press the button once. A blinking indicator light means that the camera is recording the video. Unfortunately, during flight the drone shakes a lot, making it necessary to stabilize the video. For this, I recommend using the free program GyroFlow, which is available for different operation systems. In this video, I will demonstrate the basics, and you can explore the program in more depth on your own. Load the video from the SD card into the application. GyroFlow will automatically synchronize the gyro data from the camera sensors for stabilization and apply the correct lens parameters for this camera. The program not only stabilizes the video, but also corrects the fish eye effect. You can preview the result and then export the stabilized video. In the end, I would recommend getting a set of lens filters for your camera, as they are useful in sunny or bright locations. Thanks for watching, give this video a like if you found it helpful, and see you next time!